Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on voltaic cells. In our last lesson, we learned how to calculate cell potential. We used a Daniell cell as our example and found that under standard conditions, the cell potential becomes exactly 1.1 volt. We also learned that the reaction in this cell is spontaneous because it does not require a consistent application of outside energy in order to react. We discussed that concentration affects cell potential. When a cell's reactants and products reach equilibrium, there is no net transfer of electrons. In today's lesson, we are going to talk about the different types of voltaic cells that exist. We will learn examples of each type of cell, but focus more on one particular cell, the primary cell. We will learn how this cell works and look at some examples. Let us get started. A battery is a galvanic cell or a series of combined galvanic cells. They can be used as a source of direct current at a constant voltage. While batteries are not necessarily the most efficient form of energy, they do offer both convenience and portability. Batteries can be classified into two groups: primary batteries and secondary batteries. Primary batteries use redox reactions and they cannot be effectively recharged. When the redox reaction is complete, these batteries are known as dead and they must be discarded. Primary batteries are not reusable. By contrast, secondary batteries are reusable. This type of battery is often called a storage battery. The reactions that take place in these cells can be returned to their original state or reversed by recharging. Because of this, secondary batteries are much more cost-effective because they do not have to be thrown away. Using primary cell batteries can be rather expensive. Students, let us do an activity. Please match each battery to the characteristics that best define it.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. Were you able to match each battery with the characteristics that best define it? If you said that primary batteries are non-reusable and cannot be returned to their original state, you are correct. You are also correct to say that secondary batteries are reusable and can be returned to their original state. Let us carry on and discuss a few types of primary batteries. We will start by learning about dry cell batteries. This type of battery produces about 1.5 volts. Leclanché cells, which are dry cells, are used a lot because they are quite cost effective, although they do have some disadvantages. Firstly, if the current is drawn from the battery very rapidly, the gaseous products cannot be consumed immediately. Therefore, the cell resistance increases and the voltage will drop. Also, these batteries cannot be stored forever because of the type of reaction they use. Since ammonium ion is a weak conjugate acid, the zinc electrode and ammonium ion react very slowly. You might have personally experienced another one of the Leclanché cell's disadvantages. Sometimes the zinc outer cover of these batteries deteriorates. When this happens, the electrolyte can leak out and damage the appliance it was in. Since these are primary cells, they are also not rechargeable. Another type of primary cell is an alkaline battery. These are more expensive than the Leclanché cells because they can generate current for up to 50% larger than the same size of dry cell battery. The chemistry of alkaline batteries is very similar to Leclanché cells, except that the materials inside alkaline cells are basic or alkaline rather than acidic. Alkaline cells use the oxidation of zinc and the reduction of manganese dioxide to generate a current. But sodium hydroxide or potassium hydroxide is used in the cell instead of the salt ammonium chloride. Students, let us do another activity. Please explain the differences between these two types of primary cells.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. You might have said that the Leclanché cell is less expensive than the alkaline, or that the alkaline cell is able to generate current up to 50% longer than the same sized dry cell. Both of these statements are correct. You might also have said that alkaline cells use sodium hydroxide or potassium hydroxide rather than the salt ammonium chloride. This is also correct. Alkaline cells are quite handy because their potential does not decline under high current loads. This is because no gases are formed. Mercury cells are a type of alkaline cell. This cell produces 1.35 volts. Mercury cells are often used in devices like calculators, cameras, and wristwatches. The anode in a mercury cell is metallic zinc, and the cathode is mercury 2 oxide. The negative aspect of these cells is their impact on the environment. There are ongoing efforts to stop the use of mercury cells because mercury and its compounds are poisonous. In today's lesson, we learned about different types of voltaic cells, including primary and secondary cells. We also learned about specific types of primary cells, including dry cells, alkaline cells, and mercury cells. This brings us to the end of our lesson for today. Until next time, thank you, teacher. Thank you, students.